So let us start with today's session, guys. Okay. So this is what we are going to study. ASME and its history also, how that ASME started. That is also we are going to talk about, and then brief of different sections of ASME. So let us start with first ASME part, okay? Because we most of the time follow ASME standards for design, fabrication, everything. So, and it's worldwide followed code. Most of the time we use ASME. So let us discuss about what it is, how it originated, and what are the different sections of it. Okay. So ASME, as you know, stands for American Society of Mechanical Engineers, and it is a non-profit organization. The purpose of this organization is not to make profit. Okay. You'll understand it when we see the origin, how it started actually. Okay. So it's actually a collaboration, sharing of knowledge with each other. Okay. Because let us say if there are 10 manufacturers, okay, before code, okay, they must have been using some design by rule, some fabrication methodology developed during some period. Okay. That this is the set of rules, which is good. And this is how I will fabricate. They have certain rules. Okay. So if all of them come together and share that knowledge of design and fabrication, definitely a good book can be written, right? That certain rules can be written with that. Is it making sense? Say yes if it is making sense. Guys, please say yes if it is making sense that what I'm trying to explain. So that is how that ASME started. If all of the different manufacturers come together and share their know-how, written it, that this is how we'll do it. Like if some rules, all of them are following and it is giving good results, they will write it on. So, and please remember that if something is there in ASME, does not mean that it will not change. Okay. They'll keep on upgrading. That is the beauty of it. Okay. If you're not upgrading your code, if you're not taking feedback from the actual manufacturers on daily to daily basis, your code over the time will not be usable. Okay. It will become obsolete if you're not upgrading it. Okay. So you have to make a system. That is why that ASME has built so strongly. It is followed worldwide. That is the reason, because if you follow it, if it is followed by more people, it gets feedback, and that feedback system is very good in ASME. Okay. Lots of companies, people participate in that ASME member, and they keep on giving their feedback. Okay. And that is how the code is revised every 2 years now, and they upgrade whatever has been missing, because it's a continuous process, right? It has to be evolved during the period. Okay. So it has to be done by all who are doing that work actually. Okay. So you can see that 85,000 members in 135 plus countries. Okay. And if we have a strong feedback system, see how much value can be generated, right? That is how like this platform also comes. Like if we are talking, sharing knowledge, if you guys are sharing something, I can learn from you. Okay. You can learn from me. So if we come together, that learning is much more, it's multiplied. So that is how ASME is growing. So ASME was actually founded by three industrialists in the start. Okay. These are the three names. You don't have to remember these names. Okay. So it started with, like everything starts due to a failure. That time in around 1880, 1890, there were lots of failures in boilers. Okay. Boilers were the first pressurized components we used to make. The steam was in very much use, and we used to have lots of boilers. Okay. So boilers started failing in many of the parts, lots of boiler explosions, and you can understand how much catastrophic it will be if a boiler fails. Such a pressurized and steam containing component, if it fails, it was huge loss of lives. That was very difficult for people. So when the main turning point was a disaster in Massachusetts, a shoe factory where that boiler was exploded, and it led into finally meeting the people and saying, what is going wrong. We need to monitor from each step that it's like if something happened, why it happened, you have to find out, right? So to find out what happened, if everything we are making without any code and standard, every component is different, then it's really difficult to find out what went wrong. Okay, so because starting from the material procurement, design, how you welded, how you formed that vessel, what quality checks you did, each and every step is having certain steps, so total combinedly, let us say 1,000 steps are there. If every 1,000 step followed in different companies are different, again it is multiplied. Okay, I to finding the problem itself will become a very challenging. So they thought, let us make a standard, like let us common things which will follow. Like if a material will take only from ASME material, the allowable will fix to a value, only that you have to take. Okay, so no change in factor of safety. So this is how that ASME started in 1905. Okay, and that committee was formed, and it was keep on improving that committee, and that section 1, the boiler code, that was the first code which was created. Okay, and then actually section 3 also came before that, section 8, because nuclear was even evolved much earlier. So actually the section 8 division 2 is very much influenced by section 3. Okay, somewhat relaxed, but still it is follows the path of section 3. Okay, now let us come to what are the different ASME codes which were finally which we are following now for different applications. Okay, so section 1, like we discussed, was the first code which was created, and that was for power boilers. Okay, so see, what is the main difference in boilers? We can also design by section 8 division 1. Okay, but what is the main difference? Anybody can tell section 1 and section 8? See, boilers can be designed by both of these codes, but what is the main difference? If you read the name of the code itself, it will clarify. So section 1 is for fired boilers. So direct firing, that inside the vessel firing will happen. Yes, very rightly meant, Munendra. So section 1 covers direct firing. Okay, and section 1 covers direct firing. Section 8 is unfired power boilers. The firing will be outside, like a combustor will be there, and then from there that hot gases will be taken in for steam generation. Okay, so that is the main difference. So section 1, power boilers are designed with section 1. So now before we go in these sections, let us understand the overall construction of this code. Okay, so the code will have certain sections which we can call it as a design code. Design code means it will cover, it's not like it will cover only design part, but it will cover all the cycles. Okay, starting from material to design, fabrication, quality. Okay, but now there will be certain sections which will be common, like section 2, which is for material. It will be followed by all the design codes. Okay, so if you see section 2, that is the reason if you refer part D, there are lots of different tables, for the stress value, right? So you might have already seen that. So why that different tables are coming into picture? Because it refers to different design codes. Okay, similar to material, there is one more column, one more section, which is how to do quality check. related to non-destructive examinations, ND, which we call. So section 5, which is related to non-destructive examination, it caters to all the different design codes. Section 9, which is related to welding, it caters to all welding related procedures. So now that I'll ask one question and I'll like all of you to respond. Okay. And that question is, if section 5 is covering non-destructive examinations rules, so like section 8 division 1 does not cover it, is it like that? Whether section, okay, let us start with that. Whether section 8 division 1 does not talk about non-destructive examination, my statement is correct or wrong? If I'm making a statement that section 8 division 1 does not cover any quality or non-destructive examinations related paragraphs, is it correct or wrong? Yes, it talks. Okay. Muhammad, I'll come to that what is about procedure and what is about acceptance limit. Okay. So everybody is agreeing. Please respond, guys. That is the energy. Like, I can see only 4 or 5 people are responding. Just respond. That is the way to communicate that you guys are with me. Okay, and I'll also be encouraged. Otherwise I'm just talking to a screen. Nobody is there. So only through chat we can transfer our energy. Okay. So Sanjay Sharma is also saying it covers. Okay. So if I make a statement like that and it is wrong, right? So then if both this, like if we are agreeing that section 8 division 1 also covers about non-destructive examination, then what is the difference? Like there will be confusion, right? Which one to follow, whether we follow section 5 or we follow section 8 division 1. Which one to follow? Because both are giving non-destructive examinations related chapters. Then don't you think it will become confusing that or contradicting sometime? And if section 5 is catering to all the different codes, then why don't we follow the section 5 chapter for that particular code? Are you getting my question? I'm asking if section 5 covers procedures. Yeah, Sanjay Sharma is talking now. So that Munin, which you were telling that section 5 is actually based on how to do it. Okay, section 9 will also focus on how to do. Okay, so the general section 5, the non-destructive examination, they will mention about the procedures to perform that test. Okay, like liquid penetration examination is there, non-destructive examination is there, and RT or UT or MT. So it will cover the procedure part of it, how to conduct. Okay, so now if I conducted radiography, okay, so procedure will be same for all, how to place source, what should be the distance, where to keep the film. Okay, so finally, if I have the film, till that the procedure is common for all the codes. The difference is when we start reviewing that film, whether that film, the defects, each weld will have some defects. Okay, now it is acceptable to my design code or not. Please listen to it very carefully. So that defects which are there, each weld will have some defects. Okay, it's not like you'll have completely defect free, but now there is acceptance guideline for that defect which is mentioned in the different design codes. Same defect may be acceptable for division 1. Same defect may not be acceptable for section 3. Making it clear? Yes, say clear if it is, or if you want me to explain again, I can do that. This is very important point, the differentiation between the different code. Say yes if you have understood. If you want me to explain again, just write explain. Yes, come on fast, very clear. Please come again. Okay, yes, not clear. Yes, okay. So there are few who are, please respond, guys. Please respond. Then only I'll be able to know that whether we are in line, because I cannot see your faces, so I'm not able to make it up whether you got it or not. Yes, so I'll just explain again because it's a very important part. So what I'm saying, section 5, so if you talk about only that ND, okay, RT, okay, so to understand it perfectly. So like how to perform RT, that will be given by section 5. So I will apply section 5 when I'm going to do radiography examinations. Okay. I'll keep the source. I'll take the film. See, finally, RT is what? Taking the film, right? The source will be projected on the metal, on the welding part, which you are going to inspect. Then there will be film at the end of that radiography examinations. Okay. Then film goes to a RT1, RT2, whatever, the level person, uh, NDT level person, and he will be reviewing that film. So when you are reviewing, so you'll have lots of defects. Okay. Now the defects are acceptable or not. So what fair design code will come into picture? They will mention the criteria. Okay. Like if you got a linear defect, what is the permissible length of the defect? Okay. If you have got it clutter of porosity, okay, what is the size of porosity your closed defects permitted? Okay, so if the code is very stringent, like section 3, it will give very, it will accept very thin defects. Okay, that length, let us take example like 1 mm length. If it is acceptable in section 8 division 1, the section 3 will specify 0.1, 0.2 mm. 1 mm will not be acceptable. You have to then correct that. Okay, I'm just taking it as an example. Don't take that value as a code value. Okay, so if you go to section 8 division 1 section, it will give you the acceptance of that film. How to accept, like if my design code is section 8 division 1, what types of defect I can accept? Is it clear? So section 5 will talk about how to do it, whether to accept it or not. That will be governed by the specific design code. That is that in the nutshell. Please say if you have understood. Yes. Okay. Great. Okay. So Jairam is saying, yes, please correct me if any difference on understanding procedure and method as per section 5, acceptance as per. Yes. Very rightly, Jairam. So that is what I'm trying. So procedures, how to conduct is given in this section 5. How to, whether to accept that or not. Because see, if you are doing welding, there will be defects, but it may be acceptable. Defects are also acceptable. Okay. So there, but if they are bigger, then there are limitation given. Like if the cluster of defects are happening, okay, what should be the size of that cluster? What is acceptable? What is not acceptable? That is given by the design code. Okay, great. I think I have clarified that. So section 2 is also similar. It falls into that category. It is catering to lots of different codes. So if you see there are different tables, stress tables given, right? So if you are referring as allowable stress from section 2, you should be very careful which table you are referring. Okay. So for section 8 division 1, that table 1 is there. For different sections, different tables are there. From there, you have to pick the allowable stress because factor of safety is different. And allowable stress directly comes from factor of safety. See, there is no factor of safety mentioned in the code separately. Okay, this is also, you should remember if you're not clear. So factor of safety comes attached with your allowable stress. Okay, allowable stress takes care of your factor of safety. Okay. So that is section 2 about materials. Section 2 is having different parts. Part A, which will have specification for material. Okay. mainly ferrous material. Part B is for non-ferrous. Part C is for welding, electrodes, that kind of material specification. And part D talks about the stress values. So generally, we refer, as a designer, many times we refer part D. So that talks about the allowable stresses, tensile stresses, lots of physical properties, modulus of elasticity, density. All of these are covered in section 2, part D. Okay. Now comes section 3, which is also having lots of different classes. Like there is a section NB, there is NC, ND, NF, lots of different classes are there based on where that part is, associated in that nuclear island. If it is completely in the core, then it will be NB. Okay. So requirements are also similar to that. If it is NB, that will be more stringent. If it is NC, ND, it will be slightly relaxed. Okay. Section 4 is also, generated lot before, because that is related to heating boilers. That cold countries, there was always problem of, they wanted room heating arrangements. So this was started for that purpose. So now it is even used in industries also. But the start point was to keep your room heated, that Canada and European countries where we have very cold climate. So they use this, heating boilers to heat their full building. Okay. Section 5, we talked about, it is a non-destructive examination. So the procedures, how to do LP, how to do RT, all these procedures will be mentioned in section 5. Okay. Section 6 is about recommendations of how to take care of your heating boiler. That section 4, which we talked about, the design by rule. This is a recommendation for how to take care of that, what operations we should perform to keep that in operational. Okay. Section 7 is about same thing, caring for power boilers. Section 1. Okay. So not very widely used. If you are using section 1, maybe in that time you may have to refer, because it's very specific applications. So normally what we follow as an industry in oil and gas, petrochemical, pharma, all the different industry is section 8, because most widely used code. It is also have section 8, division 1, division 2, division 3, three different divisions. Division 3 is very rarely used, but in nuclear even we have used division 3 also. Very high temperature. That was a 12-meter dia spherical vessel for nuclear purpose. So that was designed as per division 3. But other than that, you have already used all the time. You have used division 1 or division 2. Division 1, you can say it's designed by rule. Okay. Design by rule means we can calculate the thicknesses by formulas, available formulas. We can make Excel sheet, or we can, on the notebook, we can calculate all these formulas. Division 2 is having two parts, part 4 and part 5. Part 4 is governed by design by rule. Part 5 is by design by analysis. Okay, so we have to perform a numerical analysis, okay, by using different softwares which are there, but mostly ANSYS is the software which most of the people are using. So that is section 8. Okay, that is the most widely used code, and our next webinar will try to focus on that what are the, how it is constructed, what are the different sections in it. Okay, how these three, division 1, division 2, division 3 are differentiated, what is the main basis, that also we'll discuss. So we'll keep engaging with you. We'll try to have these kind of seminars very regularly. Okay. Section 9 will be it's related to welding. We all know that. Section 10 is like very recent, when fiber reinforced plastic pressure vessels are started, so then this section 9 came into section 10 came into picture. Section 11 is for nuclear in-service inspection. So if you are doing in-service inspection of a nuclear power plant, what are the set of rules that you will see in section 11. Section 12 is for transportation, that whatever fluid you are transporting, you may have seen the bromine tank, so these are the tanks which are used for transportation. So there are certain rules related to that. So if you have to design a tank of which will be used for transportation, you have to follow section 12. Okay. So then there is a section 13 also. It's a rule for overpressure protection. So we use these devices in case of surge of pressure, if whatever we intended, if the pressure is exceeding because of some failure, because in power plant, the failure are meant to happen. Okay, it will happen. You have to provide a system to take care of that. If some failure happens, how to tackle that? It should not become a catastrophic failure generating some explosion or fire. So to prevent that, we follow lots of systems. So section 13 is related to overpressure protection, because these are the 13 codes of ASME, and I think I have explained the different uses of it. Okay, the different sections where we use them. Okay, most widely is section 8 division 1. Almost 95% time you will be using section 8 division 1 in day-to-day life. Even section 3, when the nuclear island, when we work, many equipments which are outside as a utility, they're all designed by section 8. Okay. So in the plant, you may have some specific equipment related to section 1 or section 3, but there will be always equipments related to section 8. Okay. So that is how the section 8 division 1 is important. So key benefits, definitely, the code promotes the professional and passions of mechanical engineer trying to formulate the different rules to take care of any problem. Okay, so if you faced any problem, try to see where it originated, what went wrong, and then modify your code according to that. It's a continuous process. Okay, so lots of facilities it provides, like trade becomes easier. It is also improves your quality of your component, if you follow a particular code. Okay, because quality is the topmost focus of these codes. Okay, so lots of benefits are there, and definitely it's a kind of gift to us as a mechanical engineer, right? A book of all the knowledge compiled together and given to us. It's a blessing. So that is our Gita and Bible and Quran for a mechanical engineer. All the set of rules are there. Okay, we can refer it anytime, and we can give the advice, guidance to others. Okay, if we understand that code. So that is where our, if we are able to understand these parts, it will be really helpful for us in, long terms, because we can explain. See, only knowing that software part of it, like, many times people focus on that. I need only PVElite software. I want to learn that. But only learning the software will not help. You have to understand the code as a design engineer. That is the main job of ours, to read and understand different clauses. Okay, and there are lots of clauses. You cannot mug up all that. For certain application, you may have to refer certain. So it's a journey, which you have to follow and keep on learning. Okay, that is the main intention. Okay,